Carl wrote a list of 10 distinct positive integers. Each integer, apart from the first, is a multiple of the previous. The last of the 10 is between 600 and 1,000. What is the last integer? So the last integer is going to be a product of all the other ones. And if it's going to be A, B, C, D, E, F, G, like 10 of them. 4, 5, 6, 7, 8, 9, 10. Okay, and we need that to be between 600 and 1,000. Now this will get big very quickly if you just times by any old integer. For example, 1 times 2 times 3 times 4 times 5 times 6 is 720. But I've only actually used 6 integers here, so we're going to have to try and use small integers. Now it makes sense. Like let's find out. Presumably it's going to be the smallest number possible. So I'm going to start with 1, but then I can't make any of the other numbers 1 because we're told that they're all distinct. So then I'm going to have to times by 2 for the second one. So that will give me 1 and then 2. And I can just keep working my way up. 4, 8, 16, 32, 64, 128, 256. These are just, I'm just times them by 2 every time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well actually, if I do this, then I don't have enough. So I'm not necessarily finding the smallest. What would be the next possibility? Instead of timesing by 2, I could times by 3. So that would be 750 plus 6. That would be 768. Okay, if I times by 3 twice, then I think actually it would be too much. So let's say I got to 128, and instead of timesing by 2, I times by 3, and then by 3 again. Then you can see that this would be greater than 1,000. So that's got to be it, really. I just kept timesing by 2 to keep it kind of as small as possible, but each integer distinct. And when I got to this point, 512 was too small. That is the smallest number that could follow this pattern. But because it's between 600 and 1,000, I instead times by 3 here, and I got my 768. I then showed that if I times by 3 twice and just by 2 all the other times, then it would be too big. So that is the answer to this question. Now, when I did it, I didn't actually think of it like that. I actually wrote down, I thought like, oh, I don't quite know what to do. So I wrote down all the numbers as a product of their prime factors and then kind of figured it out from there. Because 600, I'm not going to like do all the derivations, but 640 is 2 to the 6 times 5 times 2 times 1. So I could only get 9 numbers from this. So there's no way that it could give me 10 integers. I could do 1, then 1 times 2, then 1 times 2 times 5, and so on. But I'm only going to get 9 numbers. And the same actually goes for some of the other ones. Actually, 729 is equal to 3 to the 6 times 1. I only get 7 numbers. So I actually figured it out by trial and error. But I would, this is obviously the way I went through it is the best way because you can do it without actually requiring the multiple choice. So yeah, 768 is actually I didn't write it down, did I? But it's 2 to the 8 times 3 times 1. So you see now we actually get 10 numbers, whereas 840, I think at this point, actually, I figured out that, I've got 10 numbers and none of these other ones are going to work. So I didn't actually worry about finding the product of prime factors. But two different approaches. This way, does get you there in the math challenge, but the best way is to think, what are some possibilities? You've got to keep the numbers small. 2 is going to be the smallest. Keep working your way up. Rule out 512. Rule out this one here. So it's got to be 768. So I hope that makes sense. I've tried my best to explain different methods for this question.